There is a recall for the following ideal in SurePerson connectors: 30.12 in SurePerson 2-port box of 100, 30.13 in SurePerson 3-port box of 100, and 30.14 in SurePerson 4-port box of 100. The recall is because connectors manufactured in the United States did not meet Ideal's quality standards. Ideal has instructed customers to return affected connectors to the place of purchase, where they will be replaced with connectors manufactured in China. While there have not been any widespread reports of problems with these connectors, Ideal has stated that they may not meet their performance expectations. If there are concerns about the recalled connectors or an exploration of an alternative is desired, the following may be considered. Waco walnuts. These reusable wire connectors are another popular option for ballast replacement and fixture connections, offering a twist-free connection, and are available in various sizes. 3M Scotchlok connectors. These connectors are available in a range of sizes and offer a reliable twist-on connection. Ideal Ensure twist-on connectors. Ideal offers a similar line of connectors that use a twist-on design instead of push-in. If any of the recalled connectors are on hand, it is recommended to return them for replacement as soon as possible. While they may still function, Ideal has determined that they do not meet their quality standards. Let's delve into the technical aspects of wire connectors, focusing on the Ideal and SurePerson connectors and their alternatives, to understand the implications of this recall and how to ensure safe and reliable electrical connections. Wire connectors are essential components in electrical systems, serving to join two or more wires together to create a continuous electrical circuit. They provide a secure and insulated connection point, preventing short circuits, electrical shocks, and other hazards. The Ideal and SurePerson connectors, specifically models 30.12, 30.13, and 30.14, are designed for quick and easy connections, particularly in applications like ballast replacement and fixture connections. These connectors utilize a push-in mechanism where wires are inserted into the connector and internal contacts create a secure connection. The recall of these connectors, specifically those manufactured in the United States, raises concerns about their quality and performance. The fact that Ideal has determined that these connectors do not meet their quality standards suggests potential issues with their construction, materials, or manufacturing processes. While there may not be widespread reports of failures in the field, the potential for substandard performance warrants caution and adherence to the recall instructions. The primary concern with substandard wire connectors is the potential for compromised electrical connections. A poor connection can lead to increased resistance, which in turn generates heat. This heat can damage the connector itself, the surrounding wires, and even the electrical equipment being powered. In extreme cases, overheating can lead to electrical fires. Furthermore, a loose or intermittent connection can cause flickering lights, malfunctioning equipment, and other electrical problems. Therefore, it is crucial to use wire connectors that meet recognized safety standards and are appropriate for the specific application. The Ideal and Sure connectors are typically used for connecting solid or stranded copper wires within a specified range of wire gauges. The connector body is made of a plastic material that provides insulation and protection against environmental factors. Inside the connector, there are metal contacts that grip the wires and establish an electrical connection. The push-in mechanism simplifies the installation process, allowing for quick and tool-free connections. However, it is essential to ensure that the wires are properly inserted and securely held by the contacts. When selecting wire connectors, it is important to consider the following factors. Firstly, wire gauge and type. A connector must be compatible with the wire gauge and type being used. Over or undersized connectors can result in loose or damaged connections. Secondly, voltage and current rating. The connector must be rated for the voltage and current levels of the electrical circuit. Exceeding the rated capacity can lead to overheating and failure. Thirdly, environmental conditions. The connector must be suitable for the environmental conditions in which it will be used. For example, connectors used in damp or corrosive environments should be appropriately rated for those conditions. Fourthly, listing and certification. The connector should be listed by a recognized testing laboratory such as Underwriters Laboratories or Canadian Standards Association, or CSA, to ensure that it meets applicable safety standards. Given the recall of the ideal Ensure connectors, it is prudent to consider alternative wire connector options. The alternatives suggested, such as Wago Walnut's 3M Scotch-Lock connectors and ideal Ensure twist-on connectors, offer different connection methods and features. Wago Walnuts are reusable lever-actuated connectors that provide a secure and reliable connection. They are suitable for both solid and stranded wires and are available in various sizes to accommodate different wire gauges. The lever mechanism allows for easy insertion and removal of wires, making them convenient for modifications and repairs. 3M Scotch-Lock connectors are twist-on connectors that utilize a helical spring to grip the wires and create a secure connection. They are available in a range of sizes and colors to identify different wire gauges. Twist-on connectors are a traditional and widely used option for splicing wires. Ideal Ensure twist-on connectors are a similar line of connectors offered by Ideal that utilize a twist-on design instead of push-in. These connectors provide a familiar connection method for those accustomed to twist-on connectors. When using any wire connector, it is crucial to follow the manufacturer's instructions carefully. This includes stripping the wires to the correct length, inserting them properly into the connector, and ensuring that the connection is secure. It is also important to avoid over-tightening twist-on connectors, as this can damage the wires in the connector. In addition to selecting the appropriate wire connectors and following proper installation procedures, it is essential to inspect the connections regularly for any signs of damage or deterioration. This includes checking for loose wires, corroded contacts, and cracked or broken connector bodies. Any damage to a worn connector should be replaced immediately to prevent electrical hazards. Furthermore, it is important to ensure that all electrical connections are properly enclosed in junction boxes or other approved enclosures. This provides physical protection for the connections and helps to prevent accidental contact with live wires. Junction boxes should be securely mounted and readily accessible for inspection and maintenance. In summary, the recall of the Ideal Ensure push-in connectors highlights the importance of using high-quality, reliable wire connectors in electrical systems. While the recalled connectors may not have exhibited widespread failures, the potential for substandard performance warrants caution and adherence to the recall instructions. When selecting wire connectors, it is crucial to consider the wire gauge and type, voltage and current rating, environmental conditions, and listing and certification. Alternative wire connector options, such as Wago Walnuts, 3M Scotch-Lock connectors, and Ideal Ensure twist-on connectors, offer different connection methods and features. Regardless of the type of wire connector used, it is essential to follow the manufacturer's instructions carefully and inspect the connections regularly for any signs of damage or deterioration. By taking these precautions, one can ensure safe and reliable electrical connections and minimize the risk of electrical hazards. Furthermore, understanding the National Electrical Code, or NEC, requirements related to wire connectors is crucial for ensuring safe and compliant electrical installations. The NEC provides specific guidelines for the selection, installation, and use of wire connectors in various applications. Some key NEC requirements related to wire connectors include: firstly, compliance with product standards. The NEC requires that wire connectors be listed and labeled in accordance with applicable product standards, such as UL 486, AMNAS 486B for wire connectors, and soldering lugs for use with copper conductors. This ensures that the connectors have been tested and evaluated for safety and performance. Secondly, proper sizing and application. The NEC specifies the proper sizing and application of wire connectors based on the wire gauge, type, and number of conductors being connected. Connectors must be suitable for the specific application and installed in accordance with the manufacturer's instructions. Thirdly, conductor compatibility. The NEC requires that wire connectors be compatible with the conductors being used. For example, aluminum conductors require connectors specifically designed for aluminum to prevent corrosion and ensure a reliable connection. Fourthly, enclosure requirement. The NEC requires that wire connectors be installed in approved enclosures, such as junction boxes, to provide physical protection and prevent accidental contact with live parts. Enclosures must be appropriately sized and installed in accordance with NEC requirements. Fifthly, accessibility. The NEC requires that wire connectors be accessible for inspection and maintenance. Connections should not be concealed or buried in walls or ceilings without providing access. Sixthly, torque requirements. The NEC specifies torque requirements for certain types of wire connectors to ensure a secure and reliable connection. Torque values must be followed to prevent over-tightening or under-tightening the connectors. Seventhly, grounding and bonding. The NEC provides specific requirements for grounding and bonding wire connectors to ensure a safe and effective grounding system. Grounding connectors must be identified and installed in accordance with NEC requirements. In addition to these specific requirements, the NEC also includes general requirements for workmanship and installation practices. All electrical work must be performed in a neat and workmanlike manner, and all materials and equipment must be installed in accordance with the manufacturer's instructions and applicable codes and standards. It is important to consult the latest edition of the NEC and any applicable local codes and regulations to ensure compliance with all requirements related to wire connectors. Failure to comply with these requirements can result in electrical hazards, property damage, and legal liability. Furthermore, understanding the different types of wire terminations and their applications is essential for selecting the appropriate connectors and ensuring reliable electrical connections. Wire terminations refer to the methods used to connect wires to electrical devices, such as switches, receptacles, and lighting fixtures. There are several common types of wire terminations, each with its own advantages and disadvantages. Firstly, screw terminals. Screw terminals are a traditional and widely used type of wire termination. They consist of a screw that clamps down on the wire, creating a mechanical and electrical connection. Screw terminals are relatively easy to install and are suitable for both solid and stranded wires. However, they can be prone to loosening over time due to vibration or thermal cycling. Secondly, push-in terminals. Push-in terminals are a type of wire termination that uses a spring-loaded contact to grip the wire. They are quick and easy to install, as the wire is simply pushed into the terminal. Push-in terminals are commonly used in residential wiring for connecting solid wires to switches and receptacles. However, they may not be suitable for stranded wires or applications with high vibration. Thirdly, crimp connectors. Crimp connectors are a type of wire termination that uses a specialized tool to crimp the connector onto the wire. Crimp connectors provide a secure and reliable connection and are commonly used in automotive, industrial, and aerospace applications. They are available in a variety of sizes and types to accommodate different wire gauges and applications. Fourthly, insulation displacement connectors, or IDCs. IDC are a type of wire termination that uses sharp contacts to pierce the insulation of the wire and make a connection. IDC are commonly used for connecting low-voltage wires in telecommunications, data communications, and control systems. They are quick and easy to install and do not require stripping the wires. Fifthly, wire nuts. Wire nuts, also known as Triston connectors, are a type of wire termination that uses a plastic cap with internal threads to twist the wires together. Wire nuts are a common and cost-effective option for splicing wires in residential and commercial wiring. However, they require proper installation techniques to ensure a secure and reliable connection. When selecting wire terminations, it is important to consider the following factors. Firstly, wire type and gauge. The termination must be compatible with the wire type and gauge being used. Secondly, current and voltage rating. The termination must be rated for the current and voltage levels of the electrical circuit. Thirdly, environmental conditions. The termination must be suitable for the environmental conditions in which it will be used. Fourthly, ease of installation. The termination should be easy to install and require minimal tools. Fifthly, reliability. The termination should provide a secure and reliable connection that will not loosen over time. In addition to selecting the appropriate wire terminations, it is important to follow proper installation techniques to ensure reliable electrical connections. This includes stripping the wires to the correct length, inserting them properly into the termination, and ensuring that the connection is secure. It is also important to avoid over-tightening screw terminals or wire nuts, as this can damage the wires and the termination. Furthermore, it is important to inspect the connections regularly for any signs of damage or deterioration. This includes checking for loose wires, corroded contacts, and cracked or broken terminations. Any damaged or worn termination should be replaced immediately to prevent electrical hazards. By understanding the different types of wire terminations and following proper installation techniques, one can ensure safe and reliable electrical connections in a variety of applications. And now let's shift our focus to a more in-depth discussion about the specific issues that led to the recall of the Ideal and Sure connectors and the potential consequences of using substandard connectors in electrical installation. The recall, as previously mentioned, pertains to Ideal and Sure Precision connectors manufactured in the United States, specifically models 30.12, 30.13, and 30.14. The reason for the recall is that these connectors did not meet Ideal's stringent quality standards. While the specific nature of the quality issues has not been publicly disclosed in great detail, it is reasonable to infer that they relate to the materials, manufacturing processes, or design of the connectors. Potential issues could include firstly substantive materials. The connectors may have been manufactured using materials that did not meet the required specifications for conductivity, insulation, or mechanical strength. For example, the metal contacts may have been made of a lower grade alloy that is more prone to corrosion or failure under stress. Secondly, manufacturing defects. The connectors may have been produced with manufacturing defects that compromise their performance or safety. These defects could include cracks, voids, or other imperfections in the plastic housing, or misaligned or improperly assembled metal contacts. Thirdly, design flaws. The connectors may have been designed with inherent flaws that made them susceptible to failure under certain conditions. For example, the push-in mechanism may not have provided a secure enough grip on the wires, or the connector may not have been adequately protected against moisture or corrosion. Regardless of the specific cause, the fact that Ideal deemed these connectors to be substandard raises serious concerns about their reliability and safety. The potential consequences of using substandard wire connectors in electrical installations can be significant, ranging from minor inconveniences to serious hazards. Some potential consequences include firstly, increased resistance. Substandard connectors may have higher electrical resistance than properly manufactured connectors. This increased resistance can lead to heat build-up, which can damage the connector, the wires, and the surrounding components. Secondly, loose connections. Substandard connectors may not provide a secure enough grip on the wires, leading to loose connections. Loose connections can cause intermittent power outages, flickering lights, and malfunctioning equipment. Thirdly, electrical shorts. Substandard connectors may have inadequate insulation, which can lead to electrical shorts. Electrical shorts can cause fires, explosions, and electrical shocks. Fourthly, fire hazards. The combination of increased resistance, loose connections, and inadequate insulation can create a significant fire hazard. Overheated connectors can ignite nearby combustible materials, leading to a fire. Fifthly, equipment damage. Substandard connectors can damage sensitive electrical equipment by causing voltage fluctuations, power surges, and electrical noise. Sixthly, personal injury. Substandard connectors can cause personal injury by exposing individuals to electrical shocks or burns. In light of these potential consequences, it is imperative that electrical contractors and homeowners take the recall of the Ideal and Sure connectors seriously and take appropriate action to replace any affected connectors. It is also important to be vigilant in inspecting electrical connections for any signs of damage or deterioration and to replace any suspect connectors with high-quality, listed connectors. Furthermore, it is crucial to follow proper installation techniques when installing wire connectors to ensure a secure and reliable connection. This includes stripping the wires to the correct length, inserting them properly into the connector, and ensuring that the connection is tight and secure. It is also important to avoid over-tightening screw terminals or wire nuts, as this can damage the wires and the connector. In addition to these practical considerations, it is also important to be aware of the legal and ethical implications of using substandard electrical components. Electrical contractors have a legal and ethical responsibility to ensure that their work meets applicable codes and standards and that it is safe and reliable. Using substandard electrical components can expose contractors to liability for damages caused by electrical failures or injuries. Homeowners also have a responsibility to ensure that their electrical systems are safe and reliable. Using substandard electrical components can endanger themselves, their families, and their property. In conclusion, the recall of the Ideal and Sure connectors serves as a reminder of the importance of using high-quality, reliable electrical components and following proper installation techniques. While the specific issues that led to the recall may not be fully understood, the potential consequences of using substandard connectors are significant. By taking appropriate action to replace affected connectors and by being vigilant in inspecting electrical connections for any signs of damage or deterioration, one can help to ensure the safety and reliability of electrical systems.